right, first I'm going to show you if I had x squared equals 16. How would I solve that to get x by itself? How would I solve for x here? How do I get x by itself? What'd you say? Take the square root of both sides. So then I would get x equals,
4.
What do I need with the 4? Positive, negative 4. Remember, when you take the square root of a positive number, you have positive, negative answer. Okay? If I had x squared equals 9, how do I get x by itself?
Isn't it x and then 9? X squared and the thing.
Take the square root.
Yeah, square root.
So then I have x equals
X plus negative. Yeah.
positive, negative 3. Write this down in your notes. What if I had x squared equals negative 25? How would I solve for x here?
Same way.
Huh?
Same way.
Same way, right? Take the square root. Type in the square root of negative 25 in your calculator.
5.
Type it in. Square root of negative 25. What do we get?
5.
Domain error.
You get an error. Okay? That is where imaginary numbers come in. Okay? Why do you think you get an error? The negative is what makes it an error. Okay? So what we're going to do is we're going to split it up to where the negative's by itself. Okay? How I can split that up is I can take square root of 25 times square root of negative 1. Okay? All I did was I split it up. We talked about this last year. I split this up to be equal to that. That's all I did. Okay? So I have square root of 25 times the square root of negative 1. Well, what's the square root of 25? 5. What is the square root of negative 1?
1.
Type in your calculator. Square root of negative 1. That is where our imaginary numbers come in. Okay, square root of negative 1 equals I. Okay, write this off to the side. I equals square root of negative 1. Write that off to the side. You're going to want it later. I equals the square root of negative 1. I squared, we're going to use later, that equals negative 1. Okay, what I want you to do, circle this, highlight it, star it. Okay, that is very important to us in this lesson. Okay, I equals square root of negative 1, and I squared equals negative 1. Okay, that I helps us get rid of the negative in the square root to make it possible. Okay, so if I do another example, if I have x squared equals negative 49. How do I solve for x here?
Take away separate the negative.
We want to take the square root first, and then, yes, we want to separate the negative. So I have square root of 49, and then I want to take that negative out as a negative 1. Now I can solve, what's the square root of 49? 7. What's the square root of negative 1?
Error.
What's the square root of negative 1? I. Yep.
I.
Square root of negative 1 is I. Let's do another one. If I have x squared equals negative 81, how do I solve this?
X equals x.
Take the square root, right? So how can I split that up since we have a negative in there?
81 and negative 1.
Square root of 81 times the square root of negative 1. What's the square root of 81? 9. What's the square root of I squared? I. Okay? When you get more comfortable, you won't have to do this step. Okay? When you get more comfortable and realize that we have a negative in there, you will get more comfortable and you won't have to do that step. Okay? But for now, I want us to practice this step so we're getting an understanding. Capiche? All right. Let's look at example 1. So I have x squared equals negative 5. How do I get x by itself? What have we been doing the whole time?
For
Square root. Okay? How can I split up that square root of negative 5?
X equals -5. Square root
Square root of 5 times the square root of
of
negative 1. Okay? Some of you have typed in your calculator already. What's the square root of square root of 5?
2.23.
It's like a decimal, right?
Yeah.
Okay, we're just going to leave it as x equals the square root of 5. What do I do with that square root of negative 1? We're going to put it in the front. What's that? Again, it doesn't matter, okay? But if I put it in the back, I have to be careful, okay? Because if I have, is this the same thing as what we started with?
Basically.
What's wrong with the bottom one?
It's within the square root.
It's in the square root. We don't want it to be in the square root, so you have to make sure it's outside of the square root, okay?
If it's not a square root, can you add it to that?
Correct. Yep. That last one here, x squared equals negative 72. How do I get x by itself? Square root. What can I split up the square root of 72? Sorry, how can I split that up?
72, square root of 72 and times the square root of negative 1.
Yes. What's the square root of 72? It's 8 point something, right? What we learned last year, or a couple years ago, depending on who you are, okay, we learned how to split that up. What is a perfect square that goes into 72? I'm going to tell you. 36. So square root of 36 goes into the square root of 72 2 times. So what is the square root of 36? 6. What do I do with that square root of 2? Leave it. And then what is that square root of negative 1? I. That's your answer. Okay, we're not going to spend too much time on rationalizing those square roots. Okay, but that was just a quick refresher from last year. Okay. Looking at that habits of mind question right below number 1, it says, how do you know that the solution to the equation x squared equals negative 5 must be an imaginary number? Because there's a negative, right? If you take the square root of a negative number, that's an automatic imaginary number. Okay, good job. One thing we need to talk about first, write this in your notes off to the side of example 2. The form we are going to write our complex numbers in is A plus BI form. So A is a constant. So again, constant means it has no variable attached. What's the variable? What's a variable? A letter, right? It can be any letter. Okay? BI, that is our imaginary number. That's our imaginary number. Okay? So, again, this is not in your notes. Okay, but I want to look at these examples over here. These are all in A plus BI form. Okay, that's the way we want to write our complex numbers. What is looking at this one right here, what is the A value? Yes, because we have A plus BI. So negative 6, what is my B value? What's just the B? 4. There you go. Yep. That next one, what is my A value? 7. What is my B value? What needs to go with the 2? Square root of 2. Yep. And then what is my A value for that last one? 0. What's my B value? 0.5. Remember, the B value is the number that's with the I. Okay? Before we move on, write this off to the side of example 2. I have 4, write exactly how I write it. 4 minus 7x plus negative 11 plus 9x. You've been solving problems like this for a very long time now. What operation is happening in the middle? Huh? What operation is happening in the middle? They're adding. Okay, does adding change anything of the second parentheses? No. So, since we're adding, we're just going to take the parentheses away. Okay, so I didn't change any signs. All I did was I took the parentheses away. Okay? How do I finish simplifying this right now? Combining like terms, exactly. So I'm going to take 4. What's a like term of 4? Negative 11. 4 minus 11 is negative 7. And then negative 7x plus 9x.
Negative 2x.
Careful. Positive 2x. And then that's it because we've combined in like terms. Okay? Now, when we put this with complex numbers, I'm going to use the same thing. Instead of x's, I'm going to put i's. So I have 4 minus 7i plus negative 11 plus 9i. Again, what is the operation happening? It's adding, so we just take the parentheses away, don't change any signs. Okay, how do we solve this from here now?
Same way you did it there.
Same way we did at the beginning, okay? It doesn't matter that it's I instead of x, okay? We're going to solve it the same way. What is 4 minus 11? Negative 7, and then we have negative 7i plus 9i plus 2i. Yep. And is that the form that we wanted? Remember a plus bi form? Is this an a plus bi form? Yes. Okay. So do you see the relationship between what you've been doing for a very long time to complex numbers? See the relationship? Okay. So you're thinking of combining like terms. Okay. One more thing we need to talk about is if I have this example, 6 plus 8i minus 2 minus 5i. What's the operation happening now? Instead of addition, we are subtracting. What do we think when we're subtracting binomials, which means two terms? Can the signs in here stay the same? No. Okay, remember, think you're distributing that negative or you're swapping signs the first. Keep, change, flip. Okay, so we're keeping the first set of parentheses. We're changing all of the signs and flipping in the second parentheses. So positive 2 turns to negative 2. Negative 5i turns to positive 5i. Okay, now how can we simplify this? Combine like terms. 6 minus 2, 4, 8i plus 5i plus 13i. Is that in the form we want? Yes, that's my answer. Okay, go ahead and try example 2, A and B. Pay attention to the operation that it's asking. So, on example 2A, what operation's happening? Addition. So does anything change? No. Take the parentheses away. So we have negative 4 plus 6i minus 2 minus 9i. All I did was I took the parentheses away. What do we do next? Combine like terms. Negative 4 minus 2, negative 6. 6i minus 9i, negative 3i. Is it in the form we want? Yes, a plus bi form. We're good. What do I do for the second one? What operation's happening? Negative. Subtracting. So what's happening?
Switch terms.
Change the signs, right? So I have 3 minus 2i, and then I have plus 4 minus i. And then what do I do from here? Yep, 3 plus 4 is 7, negative 2i minus I is negative 3i. Good. Okay. Another thing was multiplication. Okay, so I'm gonna make up an example here. If I have 2i times 3 plus 4i. Everyone write that down off to the side. Okay, I have 2i times 3 plus 4i. How do I know that this is multiplication?
Because there's a 2i in front of them.
Right, there's no operation here, so we can assume that that is multiplication. Okay, how do I multiply this? What am I doing?
Put 2 in
Yep, I'm distributing. 2i times 3, what's that? 6i. What's 2i times 4i?
8i squared.
8i squared. Good. What did we write on our notes at the beginning of class?
I squared equals -1.
I squared is -1. So we have to realize that right away. If we ever have an I squared, I want you to circle that so you know. Okay? What we're going to do is we're going to substitute because earlier we said I squared equals -1. So we're going to plug in -1 for I squared. So now I have 6i plus 8 times -1. Well, what's 8 times -1? -8. Am I done?
Yeah.
Yeah.
No, it's in the wrong one.
It's in the wrong form. Okay? How do I put it in the right form?
Can you flip it?
I can flip them. Yep. So it turns into -8 plus 6i.
Why do you add plus?
Because this is positive in front of here. Yep. If it was a negative there, then I would subtract. Yep. So you keep the original signs of what they were. Okay? Biggest thing is that I squared equals -1. So if you ever have an I squared, you
Why
have
did it
to...
turn to I squared?
What's that?
Why did it turn to I squared?
So if I'm taking... Good question. If I'm taking I times I, that turns into I squared. Similar thing if I had x times x, that turned into x squared.
But if I had 2 and 2, I'd still make it 4.
What do you mean by that?
Like if that there was a 2, it would still be 4.
Correct. Like multiplying. Multiplying is the same. Yes. Yes. Okay. I have to talk about is another one I want to talk about is if we have two complex numbers. So if I have 3 minus 2i and 3 plus 2i, I would write this down in your notes. How do I solve this? Do you agree that it's still multiplication here?
Yeah.
How do I solve this?
Grouping.
So they're kind of already grouped. Okay, we're still going to think distribute, but does anyone remember the FOIL method?
Yeah.
Kind of. Yep. I'm going to take 3 to both. So what's 3 times 3?
9.
3 times 3 is 9. And then 3 times 2i.
4i. 6i.
6i. Now I'm going to do the same thing with negative 2i. So negative 2i times 3.
9. 9.
Negative 2 times 3 is
Negative
negative 6i. And then negative 2 times 2, sorry, negative 2i times 2i.
4i.
Squared.
Negative 4i squared.
Negative 4i squared. What do I want you to circle and realize right away?
I squared.
I squared. So I'm going to keep everything the same right now. I'm going to worry about that I squared. What does I squared equal?
-1.
-1. What is negative 4 times -1?
4.
+4. Okay, now I'm at this point. What do we do from here? How do we simplify? Combine. Like terms. 9 plus 4.
13.
13. 6i minus 6i.
0.
Right, these two cancel each other out, so my answer is just
No I.
13. No I because the i's cancel each other out.
But then it's technically not in that form.
Technically, so our b is 0. So it's still considered in the correct form. Does that make sense? It doesn't matter if I don't have an A or I don't have a B. It's still considered the right form, even if they do get canceled out here. Yep. Questions about those? Just multiplying. Let's do these two examples. I'm going to take the fractions out. Okay, so pay attention to what I'm changing up here. We're going to go 2i times 10 minus 5i. That's for A. And then for B, I'm going to do 1 plus 2i times 1 minus 2i. Go ahead and solve both of those. On A, what are we doing with that 2i?
Nullifying it.
What'd you say?
Distributing it.
Distributing it. 2i times 10.
20i.
20i. And then 2i times negative 5i.
Negative 5i squared.
Careful, negative 10i squared. What do I want you to realize right away?
It's I squared.
I squared. What does I squared equal?
1.
Yep, so 20i minus 10 times negative 1. What's negative 10 times negative 1? Careful. Yep, 20i plus 10. Are we done?
No, switch them.
Yep. Put it in the correct form. What's the correct form? 10 plus 20i. Good. Example B here. What do I do first? Distribute. We're going to take 1 times 1 is 1. 1 times negative 2i. Negative 2i. 2i times 1.
2i.
2i. And then 2i times negative 2i.
Negative 4i squared.
Yep. What do I want you to realize right away?
Squared.
I squared. What does I squared equal?
Negative 1.
Yep, so we're going to plug in negative 1 for I squared. What is negative 4 times negative 1?
Positive 4.
Positive 4. What do we do when we get to this point?
Find like terms.
Combine like terms. What is 1 plus 4?
5.
5. Negative 2i plus 2i.
Cancel.
Yep, they cancel each other out, so we're just left with 5. They will not cancel all the time. Okay, they will not always cancel. Last thing we're going to talk about today. We kind of already did this at the beginning. Okay. It's just solving. So we have x squared plus 49 equals 0. And I have 9x squared plus 25 equals 0. How do I solve that first one? How do I get x by itself? We want to subtract 49 first. Yep, we want to get x all the way by itself. So I have x squared equals negative 49. Now what do I do?
Square root.
Take the square root of both sides. So what does that turn into?
Square root of 49 times the
Square root of negative 1.
Yep, what's the square root of 49?
7.
7. What's the square root of negative 1? I. So x equals 7i. What do I do on letter B? How do I get x by itself? What's first? Subtract 25. So I have 9x squared minus 20, equals negative 25. What do I do from here?
Divide by 9.
Divide by 9. X squared equals, I'm going to leave that as negative 25 over 9. How do I get x by itself here? Square root. What happens when I take the square root? What do we have in that square root?
1. Negative.
We have a negative. Okay, so I'm going to split it up like we always do. 25 divided by 9 times square root of negative 1. Hint here, when you have a fraction, you are going to take the square root of the top and the square root of the bottom. So what's the square root of 25?
5.
5. What's the square root of 9?
3.
3. And then what's the square root of negative 1? I. So we have 5/3 I.